Hi and Assalamualaikum. We are from Group 8. In this video, we will present the last experiment for Thermodynamics and Mechanics of Material Laboratory, which is experiment number 7, Heat Capacity Estimation and Entropy Generation. My group consists of Amirul Hakim Hamizun, Muhammad Amin Manap, Navi Raja Balasubramaniam, and me myself Aida Zaira Azhar. So the experiment was conducted on 5th of May 2021. My next member will continue the presentation.
Hi sir, my name is Navi Raja Balasubramaniam and Selamat Hari Raya sir. I will be presenting the abstract and also theory part from this experiment. So we will move on to abstract. So this experiment is conducted to estimate the heat capacity of different metals provided and also to estimate the entropy generated when these metals are dropped in a container containing water. In this experiment, heat capacity estimation with entropy generation analysis of heat transfer is performed, in which hot metal is added into a beaker with known volume of water at room temperature, covered with aluminium foil to ensure reliability of the taken data about the temperature change of the water in the beaker. Water in the beaker was heated up slightly as the heat from the metal force transfer into the water, thus resulting in the temperature change. The temperature change in water is then measured to calculate the specific heat of the metals, then allowing us to calculate the heat absorbed by the water, heat released by the metal, making it easy to get the heat capacity of the metal to identify unknown metals. And after conducting the experiment, the total entropy generated for aluminum and iron greater than copper. The experimental result is differ from the theoretical values due to some factors and error during the experiment.
Hi, my name is Amirul Hakim bin Hamizan and I will present for introduction part. Okay, for the introduction, the main objective for the experiment is to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped in a container containing water. This will be done by mixing two different substances and measuring their initial temperature, then measuring their final temperature as they come to thermal equilibrium, and the entropy generated during this process will be calculated.
The amount of heat needed to increase a body's temperature by 1 degree Celsius is known as heat capacity as we know. So as two bodies with different temperature exchange heat, the amount of heat lost by the warmer body equals to the amount of heat gained by the cooler body, and an intermediate equilibrium temperature is achieved. This is valid as long as no heat is lost to the surrounding. A heated solid with known mass m and temperature is lowered into a calorimeter containing known mass m2 of cold water in this experiment. After that, then only the equilibrium temperature is determined. The amount of heat lost by the solid must be same as the amount of heat gained by the water. So this is it. Heat lost by the solid equals to mcp, which is T2 solid minus T1 solid, which is temperature, and heat gained by water equals to M2 times with Cp times with the temperature of water, difference in temperature of water, and the Cp water is 4.187 kilojoule per kilogram Kelvin, and at equilibrium, T2 solid is equal to T2 water. And a system or its environment's entropy shift may be negative, but overall entropy production is still positive. A process must proceed in the direction that complies with the increase of entropy principle, which is as gen is more than zero. The entropy generation is a measure of the magnitudes of irreversibility present during the process. The entropy generated during the process is determined from which is different in S, which is MCP in times with difference T2 over T1, and the difference in S total is difference in S metal plus difference in S water. So that's all from me, sir. Thank you very much.
Okay, for the methodology, we use the metal string, thermometer, aluminium foil, three different metals, two beakers, water, hot plate, and weighing scale. Okay, for the first methodology, first step is the metal weight by weighing scale, and the value was recorded in table 1. 100 ml of water filled into a beaker, and the beaker was heated using a hot plate, and then metal string attached the copper block and lower it inside the heated water until fully submerged. Step 4. The copper are lowered inside the water until the temperature reached 80 degrees Celsius. 100 ml of water filled into the second beaker, and the initial temperature of the water was measured. Measure the temperature of water in the first beaker, and then once the heated water reach 80 degrees Celsius, the copper was taken out using the metal string, and the copper transferred immediately to the second beaker that contains 100 ml of water. Step 8, the beaker was covered by aluminium foil to minimize the heat losses to the surrounding. The temperature of the water was recorded for every time interval as in table 1 until reaching the constant temperature. Step 10, stir the water throughout the process to ensure the heat distribution, and lastly the procedure was repeated by using aluminium and iron block. Okay, that's all. Continue for this next slide.
Hi, my name is Muhammad Amin Bimanap, and now I will explain the result and discussion of this experiment. So here is table 1. All the data we will put in this table 1. So table 1 consists of time, temperature, mass of metals. So we need to find the specific heat capacity, entropy change of metal, entropy change of water, total entropy generated. So for the specific heat capacity of metals, we use this equation: heat lost by the solid equal to heat gain by the water. So for the entropy change, we will use this equation to get all of the answer for the copper, aluminium, iron, water. So we also need to calculate the total entropy generated and compare your estimated heat capacity with literature or existing data. Basically, it is percentage error. This value is due to the error during the experiment. For the discussion, we need to plot a bar chart of specific heat capacity. So for the discussion, discuss about the total entropy generated during the above process. The total entropy of a system is either increase or remain constant in any process. It never decrease. If a reversible process occur, there is no net change in entropy. In an irreversible process, entropy always increase, so the change in entropy is positive. This experiment have the positive value of the total entropy for all the metals because it is due to the error that occur. It should be zero because this process is reversible. As example, the temperature of the water will be decreased as the time increases and the metal still can be heated back. Discuss source of error and method to minimize the error. The error that we find in this experiment was parallax error when taking the readings of thermometer. Next, 100 ml of water were not measured using a cylindrical measurement. Last, the beaker was not fully isolated, so the heat will lost to the surroundings. The method that we suggest is make sure that the eyes are perpendicular to the thermometer when taking the readings. Use cylindrical measurement to measure 100 ml of water. Last, make sure that the beaker is fully isolated. Discuss justification on the importance of stirring the water in the container. Yes, it is very important to keep stirring the water when the heat transfer occur. The heat loss from the metal also can be transferred evenly in the container. The water that near to the metal will become warmer than the water that far from the metal. By stirring the water, all the water will move and make a contact with the metal, so that the temperature of the water are all the same in the container. Therefore, it will increase the efficiency of the heat transfer. Discuss justification on the importance of transfer the hot metal quickly into the water. The hot metal have a higher heat energy than the air in the surroundings. So the metal will transfer the heat energy to the surrounding and become a equilibrium state. But this experiment is to transfer the heat from the metal to the water so that we can calculate the specific heat capacity of the metal. By transferring the hot metal quickly into the water, it can reduce the heat energy loss to the surrounding and give us more accurate value for the specific heat capacity of metal. Last discussion, it is important to know the heat capacity of material and entropy generated from the heat transfer processes. Why? Yes, it is important to know both of these things. Specific heat capacity will tell us how much energy is needed to change the temperature of the materials. It also can tell us how much weight of material should we use to complete this process. The final temperature of the materials also can be estimated using the specific heat capacity. Entropy generated from the heat transfer process will show us that the process is reversible or irreversible. Basically, entropy change is either increase or remain constant. Entropy change cannot be negative. If the process is reversible, there is no net change in entropy. In an irreversible process, entropy always increases, so the change in entropy is positive. So that's all from me. We'll move to the conclusion. Thank you.
So I will conclude this experiment by using calorimetric method, the heat capacity of three metals and the entropy generated when these metals are dropped in a container containing heated water were determined in this experiment. The heat capacity of metal is estimated by comparing heat lost by the metal with heat gained by water after the metal was submerged into a water-filled container to achieve thermal equilibrium upon heating. Then the entropy generated is calculated. The percentage error is yielded by comparing experimental and theoretical heat capacity values. Copper is 75.66%, aluminum is 95.15%, while iron is 80.85%. The total entropy generated in this experiment for copper is 0.0008 kilojoules per Kelvin, aluminum is 0.0007 kilojoules per Kelvin, while iron is 0.0009 kilojoules per Kelvin. The experiment was conducted by using a container that caused major heat loss to the surroundings. Perhaps this may lead to some errors and inaccuracy. Future experiments can be improved by a properly insulated calorimeter. So that's all from us. Thank you. And we would like to thank our lab instructor, Dr. Mama Arif Sazali, for guiding us throughout this semester. And Selamat Hari Raya to everyone who is celebrating. Bye.